Hey class, this is Gigi. I'm going over number 5 in the exam review, which is asking for us to find the horizontal and the vertical asymptotes. So what I want you to be able to do is to use the definition of the vertical or and horizontal asymptote. So by definition, horizontal asymptote happen y equals some number a is a horizontal asymptote if limit as x goes to infinity of f of x is equal to that number a, or, and I'm gonna say plus or minus because it could be from either direction, from the left or from the right. And then by definition, vertical asymptote, x equal to some number b if limit as x goes to b of f of x is either positive or negative infinity. Okay, so that's the definition of vertical and horizontal asymptotes that we need to know, and that is how we are going to find the vertical or horizontal asymptote using its definition, not some rules that you have memorized before. Okay, so that's not what we're going to do. We're going to go ahead and use the definition, the limit definition, that is. Okay, so then here we would say, let's take the limit as x goes to infinity of 2x to the third plus 10x squared plus 12x divided by x to the third plus 2x squared. Okay, now so we could do this a couple of different ways using the L'Hopital's rule, or we can just go ahead here, divided by x to the third, both the numerator and the denominator. And when we do that, we would say limit as x goes to infinity of 2 plus 10 divided by x plus 12 divided by x squared over 1 plus 2 divided by x plus, actually that is it. That's the only two terms there. So when x goes to infinity, this goes to 0, this go to 0, this go to 0, so that leaves us with 2. So then we would say the horizontal asymptote is y equals to 2. Okay, now consider approaching from the left-hand side as well. In this case, approaching from the left-hand side, we still get the same answer, okay? Because there's nothing that's different here that's going to change that, that answer, even if x is negative instead of positive infinity. So we would say y equal to 2 is the only horizontal asymptote for the function f of x. Okay, now vertical asymptote. Vertical asymptote is when the function is going way up or way down, and this function is a rational function. So it's a fraction, and a fraction is big when the denominator is small. So we're looking at the suspects for b, right? The suspects for b here would be when the denominator is approaching 0. So let's, before we do that, let's go ahead and factor, because it looks like this is factorable here. X squared on the denominator, I have x plus 2, and then on the numerator I can factor out an x, and then I have actually 2x, and so I would have x squared plus 5x plus 6, which can be reduced further to 2, and then x actually divided by x on the denominator, and I would have 2, and this would be x plus 2, x plus 3, and then I would have x and x plus 2 here because one of the x has already canceled out. And then here, this x cancel with that x. So really, our function finally is just f of x equals 2x plus 3 over x. So when x goes to negative or when x is approaching 0, that's what we're looking at. Limit as x goes to 0 from the right, and then we need to look at limit as x goes to 0 from the left. Okay, so when x is approaching 0 from the right, the numerator, 2 times x plus 3 over x, the numerator is going to be close to 6, and the denominator is going to be a positive small. So this is 6 over a positive small, and that would be positive infinity. And then when x is approaching 0 from the left, the numerator is still going to be close to 6. However, the denominator is negative small. So your function is approaching negative infinity. So in this case, what it's looking like is approaching from the right, our function goes way up, and approaching from the left, our function goes way down. So then x equal to 0 is our vertical asymptote. Okay, that is by definition what it means to be a vertical asymptote when you have infinite limit. So this is infinite limit, and this is limit at infinity.